let's have a discussion on MANOVA, multivariate analysis of variance, right? Multivariate analysis of variance. So in previous videos we have discussed the theoretical aspects. So this video we are going to have a practical demonstration. This is the RE Studio already discussed, right? You can install it and you can use it. Let's implement the theory to practical. Okay, so here is a data set. So you can see df equals to empty cars data sets. Okay, if you would like to see what is there in empty cars data set, you can see this is the table. This is the table name empty car data sets, where couple of columns are there. Mileage is there, CYL, display, HV, drag, WD, QSEC, BS, AM, gear, carbon, right? So those are the tables, and we are trying to achieve MANOVA. Okay, already discussed, right? MANOVA, it is kind of advanced version of ANOVA, right? ANOVA, there is only one dependent continuous variable here, more than one continuous dependent variable, which should be a correlations together. Okay, -1 and +1. If it comes negative, means it is negative correlated, and positive means positive correlated, but there is a range, right? 0.25 less than will perform ANOVA, 1 by 1 ANOVA, right? But if it is 0.25 and 0.75, in between that, this is medium level, and more than 0.75, this is higher level, right? So here two things, low and medium, high and medium correlations, those variables will take. Okay, so this is the, we just viewed the data, and after that COR function is there. In that functions we take MPG and WT from this data sets. We take MPG and WT. Okay, now we do correlations of two variables. COR, then give MPG variable, then give WT variable. DF means this is the empty cars data set. Go inside empty car data sets, then extract that MPG column and extract that WT column. If we see the correlations, let's see, I already given the range, right? Let's see, I have given the range. See, there is minus, negative, and 0.86, right? What it means? It is highly correlated, right? It is more than 0.75, but it is negatively correlated. Means what? One tends to increase, other tends to decrease, right? That kind of. So we are taking these variables for MANOVA model. Okay, so this is, we develop one variable dv. We bind means we are bind means MPG and WT. We make this two column to one variable, right? dv. So we are binding two column, MPG and WT column, using cbind function, and dv is, now it becomes one variable, right? And then what we do here, we will estimate the MANOVA, right? Here is the formula, right? MANOVA, then call dv. dv means this MPG and WT cbind, one universal name, that dependent variable tilde gear, right? Dependent variable tilde gear. How much gear will ultimately affect based on the gear? Is there a effect on mileage and weight? That's what we are trying to look, right? So this is data sets. DF is a data set. From there we extract gear, and from we already explicitly define this dv, right? And we have already know that gear is a variable which is inside empty car data set, right? So we are performing now summary. We have to check the summary in MANOVA. We have to check the significance, right? Let's see what happens. PILLAI, PILLAI text, PILLAI test we have to do, okay, in order to see the overall summary of the MANOVA model. So look what happens. Summary MANOVA gives this is two, right? Two variables looks significant, right? It is less than 0.05. So what it tells, if it is less than 0.05 means it is statistically significant, it tells, right? Means there is a mean difference of, there is a difference on dependent variable and independent variable, you can say, right? There is a, if gear is based on the type of the gear, that mileage and weight becomes different. That kind of analysis. Okay, so you can see 34 somewhere, right? Pillai text we have on 34. So what this 34 indicate? 34.3 of the variance in the combined variables is explained by gear. It means 30, it is kind of R square, right? 34.3% of variance is explained by gear, that predictor variable, right? So depending what they explain, MPG and weight is explained by gear variable. What is the range? 34.3%, and other remaining portions are explained by other variable. You know, so much of variables are there, drag something, right? So let's come back now. See, now let's what there is a statistically significant multivariate effect of gear on the combined dependent variable MPG and weight. See, this is significant, right? This significance, what it tells, there is a statistically significant multivariate effect of gear on the combined dependent variable, means MPG and this one, MPG and weight, right? Then what ultimately this tells, right? There is a statistically difference effect of gear on the combined variable is one assumption, but what it tells, it ultimately the vehicle with different number of gears differs significantly in their joint fuel efficiency and weight based on the vehicle gear. There is a difference on weight and what is other variable? Weight, and there is a difference on weight and mileage, right? Mileage means there is mileage, right? Fuel efficiency it talks about. So this is the interpretations. The ultimate interpretation, how it comes, this is one line interpretation. So the ANOVA results indicate a significant multivariate effect of gear on final what? On fuel efficiency and vehicle weight. Okay, so Pillai trace 0.34, we have something P is statistically significant, suggesting that cars with different gear configuration, suggesting that, remember, vehicle with different gear configuration differ jointly in MPG and weight. You got it? What it tells, based on the vehicle type, there is a differentiation on mileage and weight. Okay, kind of alternative hypothesis it accepts. Mean something we already discussed in some previous thing, right? There is a difference it tells, and it is significant. Now let's go to the effect side. There is a difference. I keep telling there is a difference, right? But what is that actual difference? What is the percentage of that actual difference? In order to see that, we have to check effect size. Second step, we have to check effect size. To see the effect size, you have to install this install.packages. Then effect size is one of the package is there in R. You have to install that as a third party package, right? Install.packages and effect size. After installing that, you call that package library effect size. Then what you do, just call effect size, this double column, right? ETA underscore squared. You said squared MANOVA. This is what you have to do. There is a statistical formula. It is long, lengthy, right? But this R made it very easy, 2 lines code to see the effect. What is the effect size? To see the effect size, percentage of that effect size, how much both variable are observed, you can install effect size package, then call effect size, double column, then ETA underscore squared. You have to call that function, and you place that MANOVA. This is the model, you have to call that. This MANOVA you have to call here. Okay. So after that, what happens? It gives result, right? First of all, you need to know what is ETA. ETA squared n squared. It is also called ETA means n squared, right? ETA squared means n squared. We basically call in statistical n squared, right? So that how much of the change in the outcome is caused by gear. What this effect size says, what this effect square do, how much of the outcome is caused by gear. How much of the changes in the outcome is caused by gear. How much of the changes in outcome is caused by gear. Because how much of the changes means there is a two variables combined and made one dependent variable, right? That is weight and mileage, right? Something is there, weight and maybe mileage, or some two variables are there, right? By combining one variable, how much of the change, how much change in the outcome is caused by gear. Gear is an independent variable. That's what it shows, effect size, right? Now simple interpretations. Let's see what it's give. This after inserting this command, you will get parameter gear ETA2 0.34 and 95% confidence interval 0.1 in between 1.0, that value comes, it tells. So it is considered as a 34% of the here. See, considered as a 34% of the variation is explained by the gear to whom those dependent variable. Okay, so see, let's see, about 34% of the difference in MPG and weight together is explained by the number of gears. So about 34% of the difference in MPG and weight together is explained by the number of gears. That's what this effect size tells. And if we talk about simple interpretations, one-line interpretation, you can say gear has a strong influence on the fuel efficiency and car weight. You can say that. Okay. And finally, you can also make one line. The effect size indicates that gear explains about 34% of the variance in fuel efficiency and vehicle weight, showing a strong practical impact. You can say, okay, that we can consider that also. And why summary.aov and MANOVA is there? Because let's check, right? That tells only the percent of variation, how much explained. But let's say check individual, right? One by one, how that variation looks there. So that's why we used AOV. Let's see, AOV respondent 1 is there, right? 1, right? Gear, right? 1 is there. 1, what is there? Weight is there. There are two variables, right? Let's see. So one by one, when MPG and weight, right? If you consider response 1 is MPG, suppose response 1 is MPG. So first one is MPG. Look, there is a significant. Is it significant? Yeah, it is 0.05, less than 0.0. It is significant, right? So let's see what is it. Gear has a significant effect on MPG, right? Means what? Fuel efficiency differs across gear groups. What it tells? Fuel efficiency difference across gear groups. It tells, right? Different gear groups has a different fuel efficiency, right? Means what? Gear group, based on the gear group, type of the gear group, fuel efficiency might change. That's what it tells, right? If you see one by one. And response to what it tells, gear has a highly significant effect on weight, right? Response to this is also significant, right? You can say it is significant. Gear has a highly significant effect on weight too, because there is 15F statistics is 15.47 and less than 0.01, right? So what you can say, vehicle weight differs across gear group. Again here, right? Vehicle weight differ across gear group. Why it tells? Maybe vehicle based on the based on the gear type, vehicle weight might have a differentiation. That's what you can say, right? Gear has a highly significant effect on weight. Vehicle weight differs across gear group. That's what it tells. Now overall what we can say is gear significantly affect both fuel efficiency and vehicle weight with a strong effect on weight. Okay. Thank you so much. Now look, there is one more important step. 4, I think so. It is 3, 4. I think 4. I think so, right? I think so, right? Post hoc test we need to do. Why we do post hoc test? We need to say the difference between groups, right? There is a 3 group gear is there, 4 group there is there, 5 group gear is there. Maybe 3 to 4 is one pair, 4 to 5 is another pair, 6 to 7 is other pair. Likewise, some example, there might be a pair, right? So to see which pair, that's why we do post hoc test. Okay, like in one way MANOVA we do post hoc test, right? and see which pair is give best kind of thing we have done already in previous session, right? So here also we do post hoc test, but this post hoc test is little bit different than previous one way ANOVA. Okay, in order to do post hoc test here, post hoc test using LDA after MANOVA. So from here significance level is raised, MANOVA is significant, then we have already tested effect size, right? Effect size, what we see the percentage of changes is explained by independent variable, that's what we see. Then we do post hoc test. Which group is that? That's why we do post hoc test. But here we do LDA, linear discrimination analysis, something, right? So we do post hoc test through LDA after MANOVA, okay? After achieving MANOVA significance, that you should understand. So MANOVA tells you that different exist between group. So what it tells? MANOVA already tells you difference exist between groups. So okay, fine. It does not tell you which group are different or how they differ, right? Here, MANOVA significance level, what it tells? It tells that different exist between group. It tells that, right? Groups means what? There is a two predicted variable, that is weight and mileage, something, two, right? Weight and mileage, and another one is gear. So we found that based on the gear type there is difference in mileage and weight. So that significance table already tells that, but there we need post hoc test, because which group are different or how they differ, but group is not displayed over there, right? That's why to see the group difference we use post hoc test, LDA, okay? Post hoc test means in MANOVA LDA, linear discrimination analysis, something, okay? Discriminate here, discriminant analysis LDA, from we have to install it first, okay? From mass library we have to install mass library, then we can do discriminant analysis LDA. This one we'll talk in next part because it is longer video. Thank you.